probabilities by using probability tables, or just by using tables. So we have some information that's in a table, and we want to use this information that's in the table to calculate a probability. So the best way to explain this is with a simple example. So we'll draw a table of how many men and women there are in a class, and how many of them drink, we'll say, tea or coffee. And everybody drinks tea or coffee, one or the other. So we'll call this lesson Inferring Probabilities.
Yeah, I told them it's not Red drink.
Oh wait, it's not quite Red Bull. What is it? Oh, it is Red Bull. €2?
Yeah.
Oh man. Alright. This better make me feel better. Right. Thanks, Faisal.
Just because it has that much.
Stephen,
Yes.
you're missing a cigarette.
I don't think that'll help my head. Right, inferring probabilities from tables. Come on, Omar. Oh, please. Now, does anybody know this verb, inferring?
I know Inferno.
Not inferno. In fact, not even close to the same meaning. Inferring?
Yeah, kinda close.
No. Guess? Not quite guess. A little bit better than guess.
Estimate.
Yeah, kind of like estimating, calculating, finding. So probably the simplest one is finding, or you could say estimating, working out, figuring out. Okay, so let's have a look at an example, like I said. So we have our table here. Okay. So we'll have male, female, huh? This is no Boston Matrix, okay?
No, it's like process, like our coursework.
Oh, is it like this? Yeah. Okay. So let's say for this particular group, 20 men drink tea and 30 women drink tea, and let's say.
What are those ones? You said in this group.
Group X, we'll call them. And 40 men drink coffee and 10 women drink coffee. Okay. Can I just scroll down a little bit? So I just put this here? Yeah? Okay. So, often with these tables, the first thing you should do is calculate totals. So, here you can see 20 men drink tea and 40 men drink coffee. So how many men in total? 60. 30 women drink tea and 10 women drink coffee. 40. So in total there is 100 men and women. Now, how many tea drinkers are there? 20 men drink tea and 30 women drink tea. So there's 50 tea drinkers. And here 40 men drink coffee and 10 women drink coffee. So there's 50. Now you notice if you add these two together, you get 100. And if you add these two together, you get 100 as well. That's not an accident. That should happen.
You're welcome.
What's this? Score. Now, why did the two add up to both make 100? Well, in this case here, you're splitting the group into men and women. 60 men, 40 women, 100 people altogether. In this case here, you're splitting the group into tea drinkers and coffee drinkers. 50 tea drinkers, 50 coffee drinkers, 100 also in total, because there's still 100 people. In the first case, you're splitting people by gender. In the second case, you're splitting people by preference of drink, but it's still the same number of people. So these two should add up to make the same number here, which is the total number of people. Okay? Yes? So our first probability question. What is the probability that if you pick someone at random from the group, that person you pick will be a male? Well, how many people are there altogether?
100.
100, yeah. And how many of them are male? Yes, 60. So, 3 out of 5. And likewise, probability that the person will be female, for example? Yeah, 40 over 100. Isn't it 2 over 5? Okay, let's do another probability. Probability that the person drinks tea.
1 over 2.
Yeah, 50 over 100, because there's 50 people that drink tea, yeah, which is 1 over 2. And the probability that the person drinks coffee? Yeah, 50 over 100, which is also 1 over 2. Yeah. Okay, now just before continuing, the meaning of a couple of symbols here. So, this symbol here for probability means and. This symbol here means or. And does anybody know this symbol?
Neither.
No. Good guess though, but not. Given that.
Oh, isn't this shape or?
For probability, I think they might be opposite to what you're used to in sets. Yeah, this is definitely and this is definitely or. This is given that. And this little symbol here, yeah, this little symbol here means not. Okay, so I'll give you an example of this. This one here, the probability that they are male and that they drink coffee. So how many male coffee drinkers are there?
3 over 5 plus 1 over 2. Times 1 over 2.
Not quite. 40 over 100, yeah. There's 40 male coffee drinkers. Yeah? Yes?
Is that 2 dots or 1 dot not?
1. Okay, let's try another one. Probability that they're female and that they drink tea. Very good. 30 over 100, which is 3 over 10, isn't it? Yeah. Okay, what about this one? The probability that they're male or female.
1.
Yeah, it has to be. There's 100 males or females over 100, which is 1 then. Yeah. Okay, so I think we're okay with these two. Let's try this one, given that next. Probability that they're male, given that they drink tea. Really masculine ringtone that is. Really. This one's a bit different here. So, just to explain, what you mean when you say this, you mean probability that they're male, given that. That means knowing that. You already know. So it's like saying, what's the probability if they're male? If you know for a fact that they're a tea drinker. So it's like saying almost, you're only looking at the people who drink tea. You know that this person is a tea drinker, what's the probability that they'll be male? So here you're picking from the tea drinkers only. Yeah. So how many tea drinkers are there? 50 tea drinkers. And of those tea drinkers, how many are male? 20. So this is 2 over 5. Let's look at the other way around. What is the probability that they drink tea, given that you know that they'll be male, because maybe you're only picking from the men? 50's on the bottom, no, 60's on the bottom, and on the top, 20, which is 1 over 3. So please note the difference between the two. They're not the same thing. Yeah, okay. What about this one? The probability that they're female, given that they're not a tea drinker. So female and they're not a tea drinker. Yeah, if they're not a tea drinker, then they're a coffee drinker, which is 50. And female, 10. So 1 over 5. Ah, but this little thing here means not a tea drinker, yeah. You get that? Yeah. Yeah, okay. So we'll look at now maybe a harder one now. When you have this written down.
Do we put the same sign on the U and the N?
U and the N.
Probability of male not drinking coffee?
Oh, if you want not a female? Is it, or?
No, male, but then the U and dash on the U.
Oh, like and not drinking coffee. No, the dash only goes on like names, like events. You don't put the dash on a U or an N. Is that what you mean?
Mm-hmm.
Yeah, it only goes on name events like tea, coffee, male, female.
But why is it out of 50?
You're looking at the non-tea drinkers?
Female non-tea.
Well, this just means look at the... This is given that, so this is the group you're looking at. So you're looking at the non-tea drinkers, and you want to know how many, or probability that there'll be female picked from that group. So the non-tea drinkers are the coffee drinkers, which is 50 coffee drinkers. This is the group you're looking at. You're picking at random from this group. What's the chance that you'll get a woman from this group?
Sorry?
Yeah.
Can you explain again the male or female?
Male, or this one? Yeah.
But I think if male and female, it will be 1.
Ah. Can someone tell me this one here, please? Probability of male and female.
It has to either be a male or a female. It can't be a male and a female.
Give me the number.
0.
You cannot pick someone who's both a male and a female at the same time.
You technically can.
No, back in 1990 you can.
Yes. Yeah. This is pre-1950s question,
Oh,
we'll
okay.
say. So this one here, you want the person to be both male and a female. They can't be both at the same time. This one here though, you're saying they could be a male or they could be a female. So this is everybody. Everybody is a male or a female. So this is one done. Is this one a bit hard? This one is and. This one is or. So in this case, you need them to be both. It needs both to be true. But you can't get somebody who's both a male and a female. And this one here is or, which means you just need one of them to be true. So they could be a male or they could be a female. Yeah. Yeah, is that okay? Yeah. Can I scroll down? Yeah. Okay. Right. Before we actually do a hard one, let me just give you a simpler one to get started. Then we'll do a hard one. So we'll have males. Well, I don't want it too simple. Yeah, here, we'll do this one. This, if you're wondering, this is question 5. So male, female, and we'll look at what grades they can get. So maybe in this class there's 3 grades people could get. And you can put the totals at the bottom. We'll say ABC. We'll be more.
A star A.
Let's not be too optimistic. ABC. I suppose we don't really need this box here because there's not going to be a number in this box. Okay, so let's put in some numbers. 2, 5, 3, 6, 12, 25. Okay. So I deliberately left some boxes empty. You'll have to figure them out. So the first one is, what's the probability that you'll pick a male from this group at random? B. Oh, sorry, not a male. Male, and that they get an A. B. What is the probability that you'll get a female who gets an A? And then C. What's the probability that an A grade student is a male? So that means, what's the probability that you'll get a male given that you know that they got an A grade? Okay, I'll give you a minute or two to try this one. Step 1, you have to find the missing numbers. The energy should make me better.
Do they write you the words, or do they write it?
No, they put it as words, so they would say, like I said in the question here, for example, the last one, C, was what is the probability that an A grade student is male? So you kind of have to,
Figure it out.
yeah, take a bit of care with your converting from English to formulas.
Why are you making this look bad?
Huh?
Why are you making this look bad?
Making you look bad? Oh, males. I'm sorry, it's just reality.
For those names are 100%. You might fit them all in.
Yeah. No, I was just thinking as I was doing the male or female thing. It's like, oh,
What's the probability of a male being a male?
yeah. Well, there's different groups now.
You can't
What
assume their genders.
Yeah, exactly. What's all the other groups?
You only name the you only know their
LGBTQ?
name, not their
Yeah, no. There's different genders: male, female, and then there's
aliens.
Other.
yeah, but the other has a name.
LGBTQ.
No. What's it called? There's one where the person doesn't consider themselves male or
Queer.
female. No, not this.
Questionable.
No. What's it called? They don't consider themselves male or female.
Is it
Almost like
possible?
a neutral. No.
Queer.
No, it's not that.
They refer to them.
No, that's totally something different.
They refer to themselves as they.
Yes, this group. They use gender neutral terms.
Humans?
No.
Homo sapiens?
Like someone in America actually sued someone for calling her a her.
Yeah. It's like this. Different.
And she actually got money out of it. Yeah. And then in the news report, they called her a her. When she was like, this person sued someone for calling her a her instead of the they or something. Her a her.
Binary. That's what they call it. Like gender binary. I think.
Ethan, In the question number 8,
Yeah.
does it mean like how many A's in the male students, or how many male students are there in total?
For A, how many A grade male students?
In total?
In total, for the whole group, yeah. So, straight away you know that this one will have a 25 down below.
Yes.
Yeah.
So I thought it was like a.
No, that one I know what you're thinking of. That's the last one where you have the line. That means in a group.
What are queers then?
Be careful using that word here. That's an offensive term to some people. So
Really?
it is, yeah. So just be careful with that one.
Isn't it like a sexuality?
It is, but it's not appropriate for you to use it. Only for them to use it. Yeah. It's complicated, I know. The closest thing that would be like that would be like in America with the N-word. It's not appropriate for white people to use it, but it could be appropriate for black people to use it, you know. It's the same thing. You shouldn't be saying that word. No, Faisal, no. I didn't say that now. We have to be polite, okay? Be a good student, please.
Only Harry can see
Okay. Mark knows all about this. I'm not joking. If you ask Mark to list all the different types of genders, he'll be able to do it. Well, maybe not all of them, but he has a good list in his mind of the different groups.
Types of gender. There's only 2 of them.
He, because it's part of business, you know, like segmentation. Yeah. No, that's Donald. This is
Mark is the nice one.
I think Donald is. I think Donald's nice too. Yeah.
He just
Mark whistles a lot. You know.
And
Okay.
he rides bike in class.
Yes, that's the one. Yes, and likes to walk through the class. Yes. Okay. Do we have this one done now?
Yes.
Yeah.
Do they
So-
know you have a YouTube channel that everything gets uploaded onto?
Yeah, but you think they're watching it?
No.
You think they go home to watch my YouTube channel? No. Right, what's the number here? Well, it needs to add up to make 12, doesn't it? So it has to be 4, yeah. Now this one here has to add up to make 25, so this one has to be 13. This one then has to be 5, which makes this one 11, 7, and 7. So male and A grade, so have 2 over 25. Female and A grade, 5 over 25.
Why is it 25 and not 12?
Because this is the whole group. I never said in it for a particular group. This is assumed to be the whole group. It's only for the last one where it's not. So this is male among the A grade students.
Sorry?
Yeah.
B, I thought 13 over 25.
Which one?
B.
Female and A.
I thought it's
Oh dear. Yes.
I thought it's 13 over 25.
Female and A? There's only 5 women who got an A here. There's the 5 of them there. And the total is 25. Yeah? There are 7 A students. So, yeah, among the A students. Okay. Okay, can we do a more difficult one now? Yeah? Okay. Right. So this one's getting a little bit harder now. Okay. I need bigger table. Okay.
Question.
So in this group, it's like at a hospital, and there's.
This is the. Okay, you missed it.
No,
I was
I
gonna say
didn't.
this is the first time you draw
What is metrical?
Yeah,
No, this is great.
a straight line, and then you round it.
It's one line.
If you can,
No, that's not like it.
yes, be amazed by it.
Okay. Okay,
Small and large.
Why so-
oh god. Yeah. Okay.
How old are you, Faisal, by the way?
What's the word?
Small and large.
No, on the top.
Success A, unsuccess A, success B, unsuccess.
You children.
Huh? I'll explain it now. Unsuccessful B. Okay. So what's happening here is people are going to the hospital and they have kidney stones. It's not important what you know what kidney stones are, but kidney stones are classified as one of two levels of severity. So you can have somebody admitted to the hospital with small kidney stones, or they could have large kidney stones. And they have two different treatments that they can get. They can get treatment A or they can get treatment B. And you would like to know basically which treatment will be better. So I would say here that the people that had small kidney stones, 81 of them were successfully treated with treatment A, but 6 of them were unsuccessfully treated with treatment A. Large kidney stones, 192 of them were successfully treated with treatment A, and 71 were unsuccessfully treated with treatment A. Now on to treatment B. 234 people were successfully treated with treatment B that have small kidney stones, but 36 small kidney stone patients were unsuccessfully treated with B. 55 patients with large kidney stones were successfully treated with B, and then finally 25 patients with large kidney stones were unsuccessfully treated with B. So we'll do some of these together. So just to get started, yeah, I want the total for treatment A, and then the total for treatment B to start with.
Does it mean like a probability or the number?
No, just a number.
356.
This is for A, is it?
Yeah.
81 plus 6
50,
plus
yeah, 50.
192 plus 71 equals 350. Okay, and then for B, 234 plus 36 plus 55 plus 25. Second. What is the probability of being successfully treated with treatment A?
273 over 300.
Yeah, it'll be 81 plus 192 over 350.
Mm-hmm.
Yeah.
39 over 50.
39 over 50.
Do we have
Why
like
you choose the first and not the second one?
What do you mean?
Rewrite the question, the probability.
Yeah.
So no
We
small.
didn't try successful.
Oh yeah, sorry. Yeah, that's not enough. Success A. So whatever that equals, that's how many people were successfully treated with treatment A, and there was 350 people treated with treatment A.
Can we write the decimals?
Yeah, if you want to. What was this one, by the way?
39/50.
39/50. Okay. D. What's the probability that you have a success with treatment B? Well, yeah, 234 plus
299.
55 over 350.
289. Over
289 over
350.
350. Now, I think it might be good actually to put these as decimals. So, this one here is 0.78, is it? And this one here? 825.
Oh.
Okay, so naturally enough, the next question is, which was more of a success?
B.
And the answer here is treatment B. So you can say that 78% of patients treated with treatment A were a success, but 82% or 83% of patients treated with treatment B were a success. So it seems like B is more successful, slightly more successful than A. Okay. Can I scroll down a bit? We have more questions here for this one. We'll need to use the table, but maybe I'll zoom out a bit. Okay. F. What is the probability of being successfully treated with treatment A, given that the person has small kidney stones? So you're only looking at people with small kidney stones. What's the probability they'll be successfully treated with treatment A?
81 over 87.
81 over 87, very good. And what's that as a decimal, please? They'll be quite high.
0.9.
What is it? 931. Thank you. Okay, G now. What is the probability of being successfully treated with treatment B, given that the person has small kidney stones? Well, that would be 234 over whatever 234 plus 36 is. Like this, yeah? Okay. Which was more of a success for the small kidney stone patients? A. Okay. I. What is the probability of being successfully treated with treatment A, given that the person had large kidney stones? Very good. Over 192 plus 71, whatever that is.
2.6.
What is the answer? 0.73. Okay. And you can probably guess what's coming up next. What's the probability of having a successful treatment with B1 if the person has large kidney stones? Is it? Yeah, it's 55 over 80, is it? What's that now?
0.6875.
So, which was more of a success for the large kidney stone people? A or B? A was more of a success.
Question.
Wait. I'm building up to something awesome here, so wait. Okay. Can I scroll down a bit? Okay. Okay. So, which was more of a success for those with small or large, which is everybody, stones?
Small A.
A. M. Compare your E answer with your L answer. In E, which treatment did we conclude to be more successful? B. In L, which treatment did we conclude to be more successful? Yes. Now both those sentences can't possibly be right. We can't say B was more successful and then later say A was more successful. One of these is right and one of these is wrong. But they seem both right at the time.
What was the question?
Compare
Resolving M?
yeah.
Okay.
Compare your E and L answer.
What is L?
This last one was L.
And
Compare
E?
this answer with this answer.
Which was more successful for A?
Strange, isn't it? If we look back at E,
What was D?
no, focus on E and L. Okay, D, yeah. At the very beginning, we worked out how successful A was, how successful B was, and our conclusion was that B is more successful than A. Fine. Now, for later in the question, we looked at the group separately. We looked at people with small kidney stones. Which treatment was better for people with small kidney stones? A. We looked at people with large kidney stones. Which was more successful? A. Everybody has either small or large kidney stones, which means if you have a small kidney stone, you should get treatment A. If you have a large kidney stone, you should get treatment A. Everybody has a small or a large stone, so that means everybody should get treatment A, which means A is more successful, which is exactly the opposite of what we said earlier when we looked at them as together. We said B was more successful. So,
What can you say which is more successful?
well, that's what I want you to tell me. I'll tell you what the answer is, but I want to see if anybody knows. So which is actually the right answer? Which is the better treatment to take?
B.
The A or the B?
A. It depends on your stones.
But if you don't know what stones you have,
Then go for A.
B.
No.
I think more B.
the treatment A is more successful, regardless if you have small or large kidney stones. So the reason why your answer earlier was different to your answer later is that the answer at the very beginning, it didn't consider if the person had small or large kidney stones. So what's happening here, can I scroll down? Yeah. It's a bit like the other example that's like this, that maybe is a little bit easier to understand, is with university admissions. An example being with like Berkeley University. So I'll give this example, it might help to explain what's happening. So let's say men and women apply to, let's just say 3 different departments: Department A, Department B, and Department C. And let's say Department C is a very easy course to get into. Department B is a kind of a medium course to get into. And let's say Department A is something like medicine, which is very hard to get into. Now let's imagine that most men, they kind of pick something more on the easy side. Some of them pick medium courses, and a very small few will pick hard courses. So do you think a lot of men will get in or not? Well, a lot of men will get in because a lot of men are picking easy course. So if you look at all the men, will most or a few get in? We think maybe most will get in, because they're making choices where they pick easier courses to get into. Okay? Now, if you look at females, let's say for this example, more of them pick difficult courses to get into, like medicine. Some of them pick medium, and some of them pick easy courses. So what do you think their success rate will be in total here? High or low? Less. It'd be lower. So if you only look at this, you might think, oh, this is not a fair university because it's letting more men in than women. But what you're missing is you're not seeing the reason why that is, because each one is making different choices. And in fact, if you look at maybe the departments individually, you might discover, okay, maybe there's more women going in for the hard course and more of them actually get in. For example, let's say there's only 10 men that apply here and only one of them get in. Then that's a 10% success. Let's say 10 women apply here. Oh no, it has to be something bigger, like 100 women apply here, but only, let's say, 11, let's say 15 of them get in. A lot of women didn't get in, but the ones who did get in, they're doing better than this part here, because this is only 10% and this is only 15%. But at the very bottom, it will look like 85 were rejected, and here 9 were only rejected. But what you're completely missing here is you're not appreciating that you're looking at two different things and you shouldn't combine them together. So it's the same thing happening with the small and the large kidney stones. It's not appropriate to look at them together. It's more appropriate to look at them separate as small and large. So the second answer was actually the right answer. The treatment, what did we say? Treatment A. Because treatment A's answer considers both small or large separately. In the first answer we didn't look at them separate, and that's why it was wrong. Okay. If you wanted to read more about this, because I think it's kind of an interesting problem, it's called Simpson's paradox. It's a situation where it looks like you have opposite answers, but you don't. It's just the way that you're calculating it is not quite right. Okay. Alright, now, I'll let you try these for a few minutes. We did question 5 and 8, or 7.
What's the answer for?
So the final answer, the true answer actually is the second one, which is treatment A, we said.
How can we compare them?
No, the comparing is, you have to realise that you have opposite answers.
Okay.
And I just wanted you to think about which was actually the right answer. It was actually A then. Okay, so homework then. 1, 2, 3, 4, 6. Huh?
Zero.
No. This is pre-yellow Simpsons.
Okay, I have a question.
Yes.
The exam, will they break down the questions like that, or will they just give it to us right away, find the
Oh no. For the exam, the probability is step by step. They will. What I mean is they will break it down.
That's good.
Yeah. I just don't think he's ever happy. What did you want me to say?
If you get easy marks, like.
Yeah. What did you want me to say?
Yeah, but you know how long this will take?
Alright, can you start those questions now? We did 5 and 7 already, so it's 1, 2, 3, 4 and 6. I can put them on the screen here if you like.
We're doing normal distribution, yes?
Semester 2.